Hello and welcome to my video 7.2 Reductions and Scale Diagrams. This video is based off the Math Makes Sense 9 textbook. Alright, so let's look at these first two objects. This one first, it's sort of like an L shape here. Reduce by scale factor of 1/2. Well, we're looking at this shape here and it's telling us to reduce it by 1/2. And it's telling us the scale factor is 1/2. Okay, so let's take all the different sides and basically just cut them down by 1/2. So we've got 4 and 4, so what we need to have is 2 by 2. And then over here we've got 2 by 2 by 2 by 2. So what we need to have is 1 by 1 by 1 by 1. 1 by 1 by 1 by 1. So you can see that we cut it down by 1/2. And it could be an irregular shape like this, but as long as you look at all the different possible sides and cut it down equally by whatever the scale factor says, all these questions are basically the same. Alright, so let's take a look at this next one here. It's also irregular. And it says reduce by 3 times. Now, it doesn't say scale factor is 3, it says reduce by 3 times. So what that means is we're going to be dividing each side, which I'm going to say that's 3, this is 6, this is 3. So this isn't the same length, but I'm going to call it 3 because it's going through corners, 1, 2, like that. So between those is 3, so I'm going to call it 3. And as long as I keep it the same and even, then it will work. Or you can just take a look at this. This distance here is 3. So let's take a look. If we reduce it by 3, 6 would be, 6 divided by 3 is 2. So now I've got 2 here. 3 divided by 3 is 1. So I've got 1. So let's go 2, 1, 1. 3 divided by 3 is 1. So it'd be 1 depth, just like this one here, right? So 1 depth, and it goes out like this by 1. And so depending on how you measure it, but you can sort of think of that as 1 and 1. Alright. There you go. So it might say reduce by 3 times. If it ever says scale factor, you know it's multiplying. But if it says reduce, I'm just going to just suggest that it could be dividing if it is actually indeed reducing. So be careful about the words and watch them carefully. Okay, so here's a picture I took of myself. Quite a beautiful image, I must say. My head is 22 centimeters tall. That's in real life. That's not in the picture, that's in real life. And if each square is 1 centimeter, what is the scale factor? Well, I tried to sort of already put some guidelines in here, and it looks like some of them might be a little bit off now that I'm looking at it. But you kind of get the picture. So it goes from here-ish till here-ish. So let's call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 9.5. Okay, so this green height is 9.5. And it says that each square is 1 centimeter, so let's call it 9.5 centimeters. Alright, so if that's the case, what's the scale factor? Well, all we're going to do is take, basically ask ourselves this question. What's 9.5 times by what equals 22? Okay, so if you do that, then you're going to, the other way you can look at it is sort of dividing. So 22 divided by 9.5 equals what? Okay, so I'm just going to plug that into my calculator right now. 22 divided by 9.5 equals 2.315 blah blah blah. So let's call it 2.32. Okay, so there is our scale factor. So what is the width of my head? Okay, let's count the red now. So 1, 2, 3, 4, 5. It's almost 5.5 again. So let's call it 5.5 times by, or maybe 5.3. Let's lower it a little bit. 5.3 times by our number, our now known scale factor, equals what is the width of my head? Well, let's do times by 5.3. All right, so the width of my glasses would be then 12 centimeters. And I measured this in real life to be roughly 13.3 centimeters. So it's pretty darn close, I have to say. So sometimes these things can actually relate to real life. And what is interesting is that you might have seen some of those crime shows where they look at a camera and then they judge how tall someone is. Well, that's actually reasonable. If you can measure any part of the image and know how much that is, like, for example, if you know my glasses size, you can tell my nose size and my mouth size and everything. So you can actually measure the rest of it based off of any part of the image that you can actually measure. And that's how you can tell how tall someone is. So some of these are kind of interesting, kind of fun, but these can be used in a lot of different situations, including like blueprints, or diagrams, or little models of what's going to be created in the future. So a lot of different cases for this. Even telescopes use the same idea. So I hope this helps, and good luck on 7.2.